Energy stored in capacitor. This is capacitor. This is charging battery. The potential is V of this battery. dQ is charge flowing. We have to find energy stored in this capacitor. Let's see capacitance of capacitor V, potential difference applied, dQ, charge flowing. Energy is work done. Now dW. We know definition V. Full integrating it. But both are variable. Why V is variable? When charge, it is supplying charge, its potential goes on decreasing. So this is variable, this is variable. dQ always variable, V is variable. But C, we know this thing. C is Q by V. Capacitance is this. So dW, dQ, V, it is Q by C. Hence, total work done. That is W, integrate करिए. C constant Q dQ or W, C add 1 to power divided by same power. This is integration. Hence, energy stored, that is U, half Q square by C. This is energy stored. But Q, CV, putting in first, energy stored, half, it is C, Q CV, Q square, C square, V square, or energy comes out to be half CV square, remember. This is energy. इससे कोई भी बना सकते हो आप इसको रिमेम्बर करो फॉर न्यूमेरिकल पर्पसेस. ये भी बन सकती है. ये किसमें है? Q और C में. Now Q और V, C, Q by V, और एनर्जी हाफ C, Q by V, V square, और एनर्जी हाफ QV. So this is energy stored in capacitor of capacitance C when potential difference V is applied. Special case. But C, epsilon naught A by D, putting it in second, U half epsilon naught A by D V square. Third, fourth, but V, ED, V is E dot dl. From there we write here is E naught d. E naught y vacuum. Epsilon naught ले रखा है. This means air is there between plates. Putting in fifth, U half epsilon naught A by d V square. E naught square d square. This d goes with this d. Or U half epsilon naught E naught square A into d. It is volume between plates, A into D. This is sixth. Energy in terms of electric field intensity and volume. Hence, energy density, that is UD, energy upon volume, energy half epsilon naught E naught square into volume upon volume. This is cancelled. So energy density half epsilon naught E naught square. It is sixth, seventh. E naught electric field intensity in vacuum. If it is medium, we can write E. So this is energy stored in capacitor. Another special case. This is special case first. Find energy density of capacitor. Second special case. Where this energy is stored. And in which form? And what cost? First point, where the energy is stored. This is that capacitor, a plus charge, so it is charged, capacitor is charged. There is electric field from this to this. The energy is stored between plates of capacitor in form of potential energy because of electric field. In which form? So this is the form, potential energy because of electric field at the cost of energy of charging battery. ये यहाँ जो बैटरी लगी हुई थी, जो चार्ज कर रही थी, चार्जिंग बैटरी, और क्या है वो, अप्लाइड वोल्टेज। Equivalent capacitance of series combination of capacitors for sake of simplicity. This is the voltage applied, this is capacitance, this is charge flowing, potential across. First, define capacitance in series. यहां से यहां चार्ज के लिए सिंगल पाथ है, सिंगल पाथ. When there is single path for charge to flow between 2 points, then capacitors are said to be connected in series, or capacitors are in series combination. Let C1, C2, C3. For sake of simplicity, we take 3 capacitors. B capacitances of 3 capacitors connected in series between A and B. Apply. क्या बैटरी लगा दी यहाँ. Apply potential difference V across A and B. Let Q charge flowing in circuit. So this will be charged through C1, Q, through C2, through C3. Let V1, V2, V3 be potential difference across C1, C2 and C3. Then V1 plus V2 plus V3 number 1. This V will be divided V1, V2, V3. But V Q by C. Why? We know this definition, C is Q by V, where C is total equivalent capacitance. Similarly, V1 charge is same, V2, V3 putting in first V Q by C, Q by C1, Q by C2, Q by C3, or it is 1 by C, 1 by C1, 1 by C2 plus 1 by C3. For n capacitors, generalize कर दो. 1 by C, 1 by C1, 1 by C2, so on. Cn. Write in words. This one, 1 by C, reciprocal of total capacitance is sum of reciprocals of individual capacitances of capacitors in series combination. So this is equivalent capacitance, total capacitance of series combination of capacitors. equivalent capacitance of parallel combination of capacitors or find total capacitance when capacitors are connected in parallel. C1, C2, C3, A, B. This is battery, charging battery. This is Q. So potential difference, this total is V. So across C1 it is V, across C2 it is V, C3 is V. So V will not be divided. Charge, some charge passes through here, some through here. So charge is divided. Figure. Let C1, C2, C3 first define capacitors in series combination. How many paths are there? 3 or many? When there are many paths, for current to flow, क्या से कितने paths have? 3. When there are many paths for current to flow, then not current for charge to flow, then capacitors are said to be connected in parallel. This is what is parallel combination of capacitor. When there are many paths for charge to flow, let C1, C2, C3 be capacitances of 3 capacitors connected in parallel between 2 points A and B. Here these are the capacitors. Apply a potential difference V across A and B. Q, charge flowing in circuit. Q1, Q2, Q3, B charges through C1, C2 and C3. Now Q1 plus Q2 plus Q3, number 1. This is charge Q. It is distributed in these 3 charges. Now Q, CB. C, equivalent capacitance. Total charge, the voltage applied. Similarly, Q1, C1V potential same. Q2, C2V, Q3, C3V. Putting in first CV, C1V, C2V, C3V. V common cancel out. C is C1 plus C2 plus C3. This is equivalent capacitance. For sake of simplicity, we have taken 3. For n capacitors, C1 plus C2, so on, Cn. In words, this is what? Equivalent capacitance, total equivalent capacitance of all capacitors. ये लिखा है हमने, ये C इक्विवेलेंट कैपेसिटेंस ऑफ ऑल कैपेसिटर इज इक्वल टू, इससे काम चला लेते हैं, इज सम ऑफ व्हाट कैपेसिटेंसेस, ये कैपेसिटेंसेस ऑफ इंडिविजुअल capacitors when they are in parallel combination or connected in parallel. So this is equivalent capacitance of parallel combination of capacitors. Show that energy stored in series and parallel combination of capacitors always equal. Let C1, C2, C3 and so on be capacitances of capacitors U1, U2, U3 be their energies. Energy of series combination US half this is energy half CV square half Q square by C. इनमें से एक लेंगे। तीसरा और है हाफ क्यू वी, सी है ही नहीं इसमें, ये नहीं लेंगे। यूएस सीरीज कॉम्बिनेशन, Q square by C, same charge flows. C is capacitance in series. Number 1, but 1 by CS, 1 by C1, 1 by C2, 1 by C3 and so on. Putting in first, US energy of series combination 1 by 2, 1 by CS, C1, C2, C3 and so on, Q square, और US 1 by 2 Q square C1, 1 by 2 Q square C2, 1 by 2 Q square, open the bracket, C3 and so on, or US, it is U1 energy of first capacitor, it is U2 energy of second, it is U3 and so on. This is energy of series combination of capacitors. Energy of parallel combination, that is UP, half CV square. ये क्यों लिया? CP for parallel combination, we know this thing. This is third. Putting this value in third, UP half CP, it is C1, it is C2 plus C3 plus so on, it is V square, open the bracket, VP half C1 V square, half C2 V square, half C3 V square. पैरेलल में पोटेंशियल सेम, सीरीज में चार्ज सेम, तो इट इज यूपी. दिस इज व्हाट U1 energy of first, this is U2, this is U3 plus so on, fourth, from second and fourth. Compare right side, दोनों equal, तो left side will be equal, therefore US is equal to UP. That is energy of series combination always equal to energies of parallel combination of capacitors. distance between plates of capacitor is decreased by 10%. Find percentage increase in energy of capacitor. We know energy of capacitor U half CV square, U half C epsilon naught A by D B square. Distance decreased by 10%. New distance will be this one. 10% decrease. What is distance left? This is distance left. Hence, new energy, that is U1, it is half epsilon naught A by D V square, or U, it is 100 by 90, 0 with 0, or it is 10 by 9, 1 by 2 epsilon naught A by D V square. U1, new energy U1, or U1 is 10 by 9 U. कहाँ से लिखा ये? This is U from first. तो इंक्रीज क्या हो जाएगी? 1 by 9. So percentage multiply by 100. So how to find percentage increase in energy? U1 minus U by U into 100. That is U1 U1 by U upon U into 100. 10 by 9 minus 1. U goes with U into 100. It is 1 by 9 into 100. %.